For the A star A puzzle, first I'm going to talk about the changes that I made to the program. The original one is on the right of the screen and my modified code is on the left. So the first modified thing is the h value function to calculate the heuristic. Uh, so we want to have the cost of moving to the left is double so that we want to check if J2 is less than J, which means the current position is to the left of the final position. We want to uh, double the distance of this horizontal displacements. Otherwise, we just add the actual horizontal displacement and return the heuristic value. And I also add a close keep track of the visitor states for the graph and also have a priority queue. So instead of pop in the original code, I use priority queue, which to expand the node with the smallest f value first. Also, I want to check if the node that we are going to expand is it in the close. If it's not in close, we expand it. And the G value is the last thing I changed. So because action to the left is cost twice, so we plus 2. And for other things, plus 1. We also fringe but append new node at the end for the fringe. For the, I'm sorry, for the close, we want to add the node to the closed. So we don't want to visit the nodes that already expanded. So next, I'm going to run a program to demonstrate the idea of it. To demonstrate the A star program, I have a small example with a start state of 1, 2, 0, 3, 4, 5, 6, 7, 8, and you can see right here. And it had a solution of 2 moves left and left for a simple demonstration. I also have a picture of it on the left. Also have a recalculated GH and F value for some node and because for easy follow. And so if I run a program, I'm going to debug it to see how everything works. Action, so if F8, you see that fringe he originally let's have the start state and close originally empty, and then we're going to remove the start state from the node from the fringe, and the node now is the start state 1, 2, 0, 3, 4, 5, 6, 7, 8, which is correct. So now we are going to expand this one. So for each action, you can see that for the start state, it can only go down or left, and anything else will skip for up and right. And then we're going to calculate the G and F value for if the down action. So you see it's a G equal to 1 and H equal to 5, which F is 6, which correspond to what we have on the left. And we're going to add it to the fringe. Same thing for the action left. I always notice that the action G is 2 because we move to the left. I'm not sure why. Yeah, we just added to the fringe. All right. So now the fringe have 2 nodes. One is for moving down, one moving left, and we want to priority queue remove expand the node with the smallest F value. So the left action have F value 4 is smallest, so we're going to expand that one first. And from this one, next we're going to can go down or left. We cannot go right because we just go left, so that we skip this. Say left. If it's right, we skip it. So the action is now down, and we want to find the F and G value, which is F is 6, and also the action is left. The F value is 4, and we also add it to the fringe. And but now the fringe have 3 nodes, and we want to expand the one with the smallest F value, which is 4 with action left. So we're going to expand it, and we can find that this node also this node have a state also the goal state, so that because we remove it from the fringe, which is goal state, so we bring the result with this. We found the solution. Just bring the solution out. I also try many heuristic for the A star. As you can see, the original heuristic we have is moving to the left is double. I have the first heuristic I try is number of time misplaced, so that if just count the number of time misplaced and return the heuristic value. Next heuristic value is moving to the left is the same, which means every move costs the same. I also have another heuristic such as moving to the right is double, moving up is double, moving down is double. And the things about moving up and down is different from moving left and right, that we have to do with I, which is the vertical displacement, checking the current position to the final position. And this is the result I have for running these different heuristic. I can find that moving to the left is going to be the same with moving to the right. And I think the reason could be because the solution we have here is have 4 right move and 4 left move. That's why you have everything the same. If every move costs the same, it actually the performance is a little worse than moving left or right cost 2. And then moving up and moving down is actually worse than moving left or right cost 2. And number of tile misplay also not is not good. It's have no greater to be 2,500, but everything have the same solution, and that's why I did for another heuristic for A star. Now I'm going to talk about a BFS graph. The original code is on the right of the screen and the modify is on the left. So the first changes that I made is that I add closed, which is to keep track of visitor states, and then also have parents to keep track of the parent states. So we don't want to expand the parent to go back to the parent. So we have node of parent equal parents dot pop 0 is additional change to prevent going expand the parent. So we have close so that we don't want to go to expand the nodes we already visited. So I check before expand a node if a state is in a close or not. And that's pretty much what I have for the changes. And the original code have a solution of let's see, nodes created is 95,000, but modified code is 38,000, so significantly improve the performance. I think the reason is because we have close, which prevented to expand the visitor states, and also have parents to prevent it to expand the parent states. So if I add the line of code of 82, if len no dot partial solution less than 18, which is similar to limited depth, so that we don't want to expand a node that has the length greater than 18. And this will save us to say from nose weighted from 38,000 to nose weighted to 30,000. Using the same start state 1, 2, 0, 3, 4, 5, 6, 7, 8 I use for A star. I'm going to use the same for the BFS demonstration to show how it works. So from the A star, the solution, the nose creators is 4, but BFS we're gonna see that it's gonna be more because BFS is level by level, and we use Q first in, first out. All right, let me debug the program. So first, close and parent is going to be empty. I'm going to 8, right? So the fringe, now we have a start state. We want to pop, expand the start state first. So with this start state, same thing, we can go down left, and we're going to add these two to the fringe and the parents. So as you can see that now is the first element in the fringe, so we're going to expand that one first. So it's 1, 2, 5, 3, 4, 0, 6, 7, 8 with action down going to be expand first. So pop 0 because it's the BFS. And with this down action, now we can go left or down. So we're going to add these to the fringe also. And next we're going to expand the left from this. So start state, we can go down left. We did down, now we have to expand the left because BFS is level by level. So you can see that is 0 now is from fringe is 1, 0, 2, 3, 4, 5, 6, 7, 8, and we're going to expand that 1 to make sure that we're doing it. So you can see the node have a state of 1, 0, 2, 3, 4, 5, 6, 7, 8, which is correct. Right. And from this from this nodes, we can go down or left, and we're going to add them to the fringe for the parents. And now we finished the first, this first level is start state, the second level is down left. Now we go to the third level. So it's a left, down, down, left. And we just continue several times. And you can see that at the end, it will be, I don't know how to break this loop. I just want to see a result. So F8 to the end. All right. We see that node square to E13. If you count it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So which is exactly all we have. What we expect from BFS. The picture on the left is a little bit not correct, a little bit for the action. It should be up, right, down, left in order, but I messed up that order a little bit, but shouldn't be a big problem for this demonstration of BFS.